A gas giant is a large planet mostly composed of helium and/or hydrogen. These planets, like Jupiter and Saturn in our solar system, don't have hard surfaces and instead have swirling gases above a solid core. Gas giant exoplanets can be much larger than Jupiter and much closer to their stars than anything found in our solar system. For most of human history, our understanding of how planets form and evolve was based on the 8 planets in our solar system. But over the last 25 years, the discovery of more than 5,600 planets outside our solar system changed all that. Gas giants, like Jupiter or Saturn in our solar system, are composed mostly of helium and/or hydrogen. In this episode of Cosmos in a Minute, we look at an exciting new discovery that gives us a window into the beginnings of these massive planets. Gas giants, nearer to their stars, are often called hot Jupiters, but there's a lot more variety hidden within these broad categories. Hot Jupiters, for instance, were among the first exoplanet types found. Gas giants like Jupiter, yes, but orbiting so close to their stars that their temperatures soar into the thousands of degrees Fahrenheit or Celsius. These large planets make such tight orbits that they cause a pronounced wobble in their stars, tugging their stellar hosts this way and that, and causing a measurable shift in the spectrum of light from the stars. That made hot Jupiters easier to detect in the early days of planet hunting, using the radial velocity method, similar in size to Jupiter. These gas-dominated planets orbit extremely close to their parent stars, circling them in as few as 18 hours. We have nothing like them in our own solar system, where the closest planets to the Sun are rocky and orbiting much farther away. The questions about hot Jupiters are as big as the planets themselves. Do they form close to their stars or farther away before migrating inward? And if these giants do migrate, what would that reveal about the history of the planets in our own solar system? To answer those questions, scientists will need to observe many of these hot giants very early in their formation. The detection of the exoplanet HIP 67522b, thought to be the youngest hot Jupiter ever found in June 2020, could expand our understanding. It orbits a well-studied star that is about 17 million years old, meaning the hot Jupiter is likely only a few million years younger, whereas most known hot Jupiters are more than a billion years old. The planet takes about 7 days to orbit its star, which has a mass similar to the Sun's. Located only about 490 light-years from Earth, HIP 67522b is about 10 times the diameter of Earth, or close to that of Jupiter. Its size strongly indicates that it is a gas-dominated planet. The discovery offers hope for finding more young hot Jupiters and learning more about how planets form throughout the universe. Imagine a vast expanse of space dotted with countless stars, each with its own planetary system. Among these systems, some planets stand out. The gas giants, these colossal worlds, mostly composed of hydrogen and helium, dominate their planetary neighborhoods. You might be thinking of Jupiter or Saturn in our solar system. And while our gas giants are indeed massive, they are dwarfed by some exoplanets. Out there, astronomers have found gas giants over twice the size of Jupiter, making them true behemoths. But it's not just their size that sets them apart. These extrasolar planets orbit incredibly close to their stars. If you replaced our Jupiter with one of these exoplanets in our solar system, it would find itself scorched by the intense heat of the Sun. Welcome to the world of hot Jupiters. But why do these gas giants prefer such toasty surroundings? Scientists believe that these planets migrated inward over time. Imagine them starting off far from their stars and then slowly drifting closer. Perhaps due to gravitational encounters or interactions with other planets. This migration would bring them dangerously close to their stellar furnaces. And while that might sound like an uncomfortable place to live, these planets seem quite content. They've even developed atmospheres with temperatures reaching over 1,000 degrees Celsius. But here's the cosmic twist. Despite their scorching temperatures, these hot Jupiters have puffy atmospheres. It's as if they've expanded to cool off. But they can't quite escape their sweltering surroundings, so they puff up and expand until they reach a balance between the heat from their star and the pressure within their atmosphere. The result is a gas giant unlike any we have in our solar system. Massive, scorching hot, and puffy all at once. Now let's turn our telescopes to an intriguing newcomer to the Hot Jupiter Club. Meet HIP 67522b, discovered in 2020. This planet is special because it might be the youngest hot Jupiter ever found. At just a few million years old, it's a baby compared to most hot Jupiters, which are billions of years old. This young hot Jupiter orbits a star about 490 light-years away and takes just 7 days to complete an orbit. With a radius nearly 10 times that of Earth, HIP 67522b is also pretty massive. Scientists estimate that it has around 13 times the mass of Earth. Its discovery has got astronomers excited because it could help us understand how these massive planets migrate inward and expand into hot Jupiters. By studying HIP 6752, researchers hope to unravel the mysteries of these strange and fascinating planets, and perhaps learn more about our own solar system along the way. Gas giants, with their colossal size and gaseous composition, dominate the headlines when it comes to exoplanet discoveries. But amidst this excitement, scientists have uncovered another intriguing group of worlds, the super puffy planets. These planets are intermediate in complexity between the relatively simple hot Jupiters and the more mysterious sub-Neptunian worlds. The term super puffy might sound like a character from a children's story, but these planets are anything but fictional. Astronomers have identified at least 20 of these bizarro worlds, each more perplexing than the last. So what makes these planets so puzzling? For starters, they are humongous, typically 2 to 3 times the size of Neptune. These planets could be mistaken for miniature gas giants. However, they have a peculiar characteristic that sets them apart. These planets have incredibly thick atmospheres. As a result, they are several times larger than expected given their mass. Imagine a planet the size of Neptune, but with an atmosphere so thick it expands to the size of Uranus. That's the kind of super puffiness we're talking about. But what causes such extreme puffiness? Scientists believe that these planets might have lost part of their atmosphere to space over billions of years. This could have been caused by intense radiation from their host stars stripping away the outer layers of their atmospheres. As a result, these planets have retained only the most tightly bound gases, leaving them uncomfortably puffy. It's as if someone had taken a balloon, let some air out, but had tied it off too tightly. The remaining air would still be trapped inside, making the balloon uncomfortably puffy. To add to the mystery, super puffy planets tend to orbit very far from their stars. Unlike the scorching hot Jupiters that sizzle close to their stars, these planets reside in the frigid regions of their solar systems. Despite their distance from their stars, these planets still retain some heat from their formation. This heat, combined with the pressure from their thick atmospheres, causes them to puff up even more. Think of it like a hot water balloon. The hot water expands, pushing against the balloon's skin, making it puff up. Similarly, the heat trapped within these planets pushes against their atmospheric layers, creating these bizarrely puffy worlds. As you can see, super puffy planets are a class unto themselves. Their immense size, thick atmospheres, and distant orbits make them stand out among the myriad of exoplanets discovered in recent years. While scientists continue to puzzle over their origins and evolution, one thing is clear: these planets are anything but ordinary. Each discovery brings us closer to unraveling the complexities of our universe. Who knows what other wonders await us in the vast expanse of space? Super puffy planets may not have the same mass as gas giants, but they certainly make an equally compelling case for our fascination. If you enjoyed this episode, make sure to leave us a like and subscribe for more updates. We've barely scratched the surface of what's out there, and your support helps us keep bringing these amazing stories to you. So stay tuned for more Cosmos in a minute.